Okay, what if I were to say what's the probability in problem 28 of falling in the shaded region? Would that work?
Yeah.
Okay, so if you're looking for the probability of selecting a point in this shaded region of this whole figure, the way that you're looking at that is you're looking at shaded divided by the total. The total meaning unshaded and shaded combined. So we found our shaded region right here. So all of these calculations give us our total shaded region. And then the whole area, the shaded and unshaded combined, is just that large outer circle, correct? So if we took the whole outer circle, which was this 12 squared pi, or 144 pi, there's our outer region. The pi's cancel. And so if you calculate the decimal equivalent for 95 over 144, so you get approximately 0.66. Okay, so there's the probability if you were converting it into decimals. 66% about. So again, if it depends what the figure looks like. Were you looking more at like one more similar to what was in the problem? And so if you're doing something like this, and let's say I gave you the diameter is 10, and let's say the diameter of this inner part here is 6. If you wanted to find the probability of it being shaded, again, you're still taking the shaded over the total. Okay, and so if you took the shaded area, you're simply taking that inner piece, so it's a semicircle. So it's 1/2 of pi r squared. Well, what is the radius of that? 3. And so we get 1/2 pi times 9, or you get 9/2 pi. And then our total would just be the area of the whole circle. The shaded is the unshaded and shaded combined. It just fits that whole outer circle. So the total circle is going to be pi times r squared. Well, what would the radius be? That one would be 5. And so you get 25 pi here. And so if you divided those through, the pi's cancel. So if you took 4.5 divided by 25, you get your answer to be 0.18 or 18%, depending on whether they ask for probability or percentage.
In the book, it had like the area of the whole subtracted by the area of the shaded over the total.
For the
It was just like an example in the book. Like,
okay, so if I gave you something like this, right here, and I asked you to find the shaded, so assuming these were all the same dimensions here, what you could do is you could take the whole thing, so 25 pi, minus the unshaded now. It becomes the unshaded part, which is 9/2 pi, divided by the whole thing, 25 pi. Okay, now, what's an easier way? Well, could you, if I had asked you in this problem, what's the probability of hitting an unshaded part? If we knew the shaded is 18, what's the probability of the unshaded? It's 82, right? So you could just find, like if this was your problem, just find the unshaded percentage, which we did right here, pretty easy calculation, and then just subtract that from 1, and that'll give you the shaded. Okay. All right. Any other questions on chapter 4?